Hello, statistics student. This video is for chapter 3.1. We're starting a probability chapter. So 3.1 is terms and definitions, and also introduce some um, outcomes that are not simple, so compound outcome. So before we get into how to calculate probability, let's introduce some terms. The first term is sample space. Sample space are total possible outcomes of a procedures. So these outcomes are by chance and equally possible. So we can list them in a set format. And to find probability, we are interested counting the number of outcomes in the sample space. So we are not interested what is the outcome, but how many possible there are. The second term is event. Event is the outcome or a result of a procedure. So these procedures, the outcome of this procedure should be determined by chance, such as you toss a die or you toss a coin. So, and usually we use A, B, C capital letter to represent the outcome. So if I write P open parenthesis A, read as P of A, that is find the probability of an event A occurring. Okay, so P of A, kind of like the function notation form, but it's not multiplying, it is actually P of A, a probability of A happening. And this is a numerical value. So in layman's term, we'll say, if we want to describe chance, we'll say, oh, it is highly likely, or it is equally likely, or it is not likely, something like that, even unlikely. But in probability, we want to calculate an actual value so that we can describe how likely an event is compared to another event. So the two extreme numbers are 0 and 1. So if something is impossible to happen, we call P of A is 0. If it's certain to happen, then P of A is 1. If P of A is, so any valid probability value would be between 0 and 1. And there are different ways of writing them, so maybe I'll talk about this after I describe this. So probability of A would be any number in between 0 and 1. So it could be 0.3, it could be 0.4. Of course, 0.4 will be greater than 0.3, is more likely to happen than an event that's 0.3. And if probability is 0.8, then it has a 50-50% chance. And then in probability by default, if we don't say anything, A is unlikely if the probability of A is less than or equal to 0.05. So I don't have it in the notes, but I'll briefly go over the way of writing the probability because it's a number. So when we write a number between 0 and 1, there is different way of writing them. One way is, of course, use a decimal point like what I have in 0.05. So you can ways of writing. So decimal would be such as like 0.01 or 1, no, cannot be 1.2, right? It can be 0.0003. So these are possible value, and usually we round to 3 places. Okay, so usual practice. And you can also write in decimal, so we can say it's 10% chance, right? 10% chance is 0.1. 10% chance that there's a rain today, or 10% chance of being accepted into a college that's very selective. So that's percentage. And also you can write a probability that is in fraction. So you can say 3 out of 10. You can say 4 out of 12, but round it to 1/3, right? So these are fractions. This is not, so if it is reducible, you should reduce it. So, but usually we don't write in fraction if the denominator is very big. So this small number is fine. 1 out of 3, this is fine. But if it's or actually 1 out of 3,244, you know that it is really low chance because there's that many possible cases and there's only one chance, right? But if it is 422 over 325, we don't use this. So we usually use decimal, okay? And we use percent when we are writing the answer in a sentence. So that is the way, but you cannot have a fraction that is, you know, 10 over 3 is not a valid probability. You cannot have a probability that's 1.2, and you cannot have a probability that is negative. But how to evaluate or find this probability number? So first approach is called theoretical probability or classical approach. It's actually count the number of ways in the sample space and count the number of ways that A actually occur in the sample space. So these are both are counts, okay? So for example, and actually in just make sure that you know the number of ways that you describe in the sample space must be equally likely. Okay. Example one, I have a jar that contains 18 red marbles, 22 blue and 6 green marbles. So if I pick one marbles, what is the sample space? So you will say the sample space would be all the different marbles that's available. Red, although they're different one, there's 18, they're same color, but I would just do 18 of the red, 20 of the blue, that many, and then the green, there's 6 of them. I list each individual, marbles. That is called a sample space. But to do the calculation, I count how many there are. Actually, how many there are. So that would be 18 plus, so the grand total in the sample space is 18 plus 22 plus 6, right? So that would be, use a calculator, 18 plus 22 plus 6, that is 46 marbles. And that would be the count in the sample space would be used for calculation. So the sample space are all the different marbles. And if I want red, so red is the one that I want, that's my favorable. So how many is in the sample space that satisfy red? It would be this 18, right? There's 18 of them. So you will say 18 counts out of 42 counts. Okay. So the one is not taken into consideration. So it's not 1 over 18 or 1 over 46. You are looking at number of ways that A can occur because you have 18 marbles, so you have 18 ways, and number of ways in the sample space. So each marbles are equally likely to be picked. So you have 42 available. So that's how you do. So because the denominator is a big number, so we don't want to write as fraction, we just do 4 to 9, round to 3 decimal places. What about probability of getting a blue? So number of ways that blue can happen is 22. Because if I look at the sample space, there's 22 blue. And what is the total sample space number? That's 22 over 42 is 42, so 0.523. And you can see that it's more likely to get blue than red because there are more ways that blue can happen. Okay, so that is how, in a nutshell, how can you do theoretical probability? You just look at number of ways that you can get this favorable outcome or successful outcome. Okay, the second example is about spinning. So this is also a random event. If you spin once, it would land on somewhere, right? What is the chance of landing on 5? So our sample space are all the possible landing, which is 1, 2, up to 6. I have 6 number, right? So 6. What is the here that would land on 5? There's only have one number, right? So it's 1 because there's 1 5. So it's 1 6. I can leave it as a fraction because this is more fraction. But if you want to, you can calculate as a decimal. So the third example is select one card from a standard deck. A standard deck has 52 cards. So in case you don't know, there is out of those 52 cards, there's 26 red card because diamond and heart are red card, right? Diamond and heart, right? A red card. And then there is 26 black card. They are club and space, right? So 13, and then each one of them, like diamond, we call them the suite, right? Each suite has A to all the way to 10, and then Jack, King, Queen. So that's 13 cards, right? So there's 13 diamond like this, 13 heart like this, 13 club, 13 space. So if I want to do probability of diamond, so I would want all the diamond card that is 13 of them because that's from A to 10 to, and then 3 face card, 13, and then one card was the total possible is 52, so it's reduced to 1/4 is 0.25 and 25%. I have all the different way of listing them. What is the chance of selecting a 6? How many card is there totally? So it's divided by the sample space is always 52 because you pick one from a standard deck. How many 6 do I have? I have 1 6 in diamond, 1 6 in heart, 1 6 in club, and 1 6 in space. So it's 4. If I simplify, it's 1 out of 13. 1 divided by 13 is 0.077 or 7.7%. So it depends on what they want. What about red card? How many red card? I have 26 red card because all the diamond and all the hearts are red. So it's 26 would satisfy being a red card, and it's 52, so it's 0.5. What is the probability of picking a face card? So I have 3 face card in diamond, 3 face card in heart, 3 face card in club, and 3 face cards in space. So 3 times 4 is 12, right? That's my favorable outcome, and I can pick one from every 52. So if I want to simplify it, it is 3 out of 13. Decimal is 0.231. Okay, so that's how you do cards. Now, there is a difference between the example 1 and 2. In example 3, some of the card has two different properties, right? They can be a red card as well as a diamond card, right? So we'll do more example on describing those. And in the later example, we'll think about what is the probability that I want just a red card, or actually a diamond card is fine like that. So, or I want a 5 or all the red cards. So how do I do that? So that would be later on. If you look at the second video, you'll see that. So what is the second way of calculating probability if you really cannot get your hands on the sample space, not because you can list all the possible outcome, because you don't know if they're likely, equally likely. So what you can do is just try. Just repeat the procedures. Actually, just do the procedure, repeat it, and count the number of times that A occur. So probability, this is an estimate, and we'll talk about why it could be useful. Okay, so I don't have the first example. My gosh, yeah, I think I have a typo here. So this should be example 1. I don't know why. I'm gonna stop here first. Oh, okay. So we were talking about, oh yeah. Well, how come I have a bang example once it turns out that this is example 1. So it say we would use something called experimental or relative frequency approximation to find probability if we don't have a equally likely sample space so that we cannot count what's the possible one. So for example, in year 2020, 86% of people use social media at least once per day. And we are going to pick someone. We want to see what is the chance that I'll pick someone that use social media at least once a day. So because 86% is the relative frequency that describe how many people use social media over the total. So the probability of picks one person is the same as the relative frequency. So that's very good. If you know the relative frequency of a particular feature of your population, that is your probability. Okay. So kind of like, oh, you know, half of the student body is female. So if you randomly select a student, what is the chance that is a female? Is 1/2, like that. The second one is when you actually have to calculate the relative frequencies. You don't know, but they tell you how many there are when you did a sample. So in this is a sample, they show um, 560 college students, 320 students say yes and to working full time, and the rest say no. So, or not sure. If one student is selected, find probably a full time. So when I say one student is selected, it's not necessarily from the sample. It could be from a general population. So you do 320, which is the yes full time, right? Over the total. So this is the total. So that would be 0.563, but it's not full time. So you would calculate it by right